Hey students, in this video we're going to dive into states of matter like we never have before. This might be a little bit of a review in parts for you. Like junior high, you learned a little bit about solids, liquids, and gases, maybe in middle school. But here in high school chemistry, we're going to take it a couple steps further and we're going to dive deeper. So for starters, what we're really interested in being able to do as high school chemistry students is, we're trying to get to a point where we can explain phenomena, things that happen in the world. Why are things the way they are? And when I say explain, I mean it's your job to construct the sentences, the explanations, for why these things happen. And that's a tough thing for a lot of students. So my goal in this video is to try to help give you the tools so that you can construct those beautiful sentences that explain the interesting things that happen in the world around us. We're trying to connect what's happening with particles in a solid, a liquid, or a gas. We're trying to connect that and the behavior of those particles to what we see in the real world, in the big world. Okay, so we in my class worked on a little simulation activity. You can find these things online if you're not one of my students and you're watching this video for something else. Go online. You can find particle simulations of solids, liquids, and gases, and you will see the features that you're seeing right here. Right, that in a solid, all the particles, in this case these are molecules of oxygen, all the particles are nicely lined up. They're just kind of sitting there vibrating and they don't leave their place. It's like a classroom with a seating chart. Okay. With the liquid, all the kids in the classroom, they can move around now, but they're still touching each other. They still have to sit next to each other. So this teacher doesn't like any empty seats in the middle of the classroom. And then in a gas, this is a totally free and wild classroom where the kids can move around wherever they want at any time. Okay, particles are moving really quickly. They fill up the space in that container. Okay, so just looking at these simulations can give you a really helpful, good understanding of what's going on at the molecular level with solids, liquids, and gases. And so let's start with the what here, right? We're going to talk about why some things are the way they are, as I said. So what do I mean by that? How are things? Well, solids, as you can see here, this solid, the whole thing, all the particles together have like a rectangular shape, and that shape doesn't change. Okay, we say that solids have a fixed shape. Okay, and what I want to do is look at that same sort of thing for liquids and gases as well. Can a liquid change shape, right? When we watch our particle simulations, we can see that the particles can move around each other. They're not stuck in one spot. The whole liquid sample can change shape, and we know this is true in the macroscopic world because think of any liquid like water. When you pour it into a glass, it takes the shape of that glass. Whatever container it's in, it takes that shape. So we say that liquids don't have a fixed shape. Liquids have a flexible shape. The shape can change. Same with a gas. You look at the particles in the simulation up here, and you can see that the particles can move all around, and the shape of the whole gas can change based on the shape of the container. And again, we know that this is true from our own experience. You can take a balloon that's perfectly round, and if you squish it, now it'll look kind of flattened out like a pancake. You just caused the gas in that balloon to change into that pancake shape, right? Gases also have a flexible shape. And then the other thing we think about with characterizing solid, liquids, and gases is the volume. If you have a sample of a solid, right? Here's a solid object, this pen. Does this pen ever change size on its own? Can it? without me breaking it? No, it can't. It stays the same size and shape. So solids have a fixed volume and a fixed shape. Liquids. If I pour myself a glass of water, do you ever see the amount of water changing on its own, right? Does the volume of a liquid just change spontaneously? No. Liquids have a fixed volume. So see, liquids are kind of special, right? They can change shape, but they can't get bigger or smaller. They can't expand or contract or compress. Gases, on the other hand, are flexible in both. They can change shape, and the gas can spread out, right? It can expand. You can expand a gas. You can compress a gas into a canister. We know these things from our life. So the exercise I want you to do here, and I'll do one or two for you and see if you can pick it up for yourself, is we want to explain why these things are the case, right? Why can't I pour myself a glass of pen, right? Why don't solids flow? Why can a gas be compressed or expand? Why are these things the case? Okay. So here's some big ideas that you should add to your notes that can help you with these descriptions. Okay, so what's going on, and you're going to be using these facts in just about every answer to these questions. Particles are always moving, even in solids, right? They have kinetic energy. They move. At the same time, right, they're trying to move around everywhere. At the same time, they're also attracted to each other. Particles pull toward each other. Okay, some substances pull more than others, but all the particles in every substance are at least a little bit attracted to each other. Okay, so there's this constant competition between those two things, right? The movement of the particles, the kinetic energy, is the thing that's telling them to move away, to spread out. But the attraction is telling them to get closer together. So there's a competition between these two. If the kinetic energy wins, right, if there's way more kinetic energy than attraction between the particles, then the particles, they break free of each other and they can spread out. On the other hand, if they don't have much kinetic energy, but they do have a very strong attraction toward each other, well, then they're going to be stuck together, and those attractions are going to win. Okay, and all the particles are just going to stay in place and vibrate there because they can't break free of each other. They don't have enough kinetic energy to break free. And then in between, right, we've got states of matter, like a liquid is in the middle, where it's somewhere in between, right? There's kind of a balance between the kinetic energy and those attractions so that they're still staying close together, but now they can move around inside of the sample of liquid. Okay. So, question, why do solids have fixed shape and volume? I'll do this one for you, okay? In a solid, let's look at our particles, right? Why doesn't my keyboard ever change shape on its own? But liquids and gases do, right? Liquids and gases have flexible shape. Okay, solid particles, they're stuck in place. You can see that in the particle simulations online, that the particles never move out of their place. They're stuck. Why are they stuck? Because in a solid, the attractions between the particles are winning. They're much stronger than the kinetic energy. They don't have enough kinetic energy to break free of those attractions. Okay, so we can put that into a sentence. In a solid, the particles are strongly attracted to each other. The particles don't have enough kinetic energy to move around. They are stuck in one place. Okay, so since the particles are stuck in one place, the whole shape of the whole solid stays the same because none of those individual parts can change. Okay. So there we go. That's why solids have a fixed shape and a fixed volume. You know what? I was talking mostly about shape here, but the volume, why can't the solid get bigger or smaller? Well, that's very similar, right? The particles are stuck in place. Also, since the particles are stuck in place, they can't spread out or get closer. Right, they're stuck in one place. If you want a sample of something like a gas to get bigger or smaller, then there needs to be space for the particles to expand and move away from each other or get closer. Okay. So gases are the opposite of solids. Why do they change their shape? And why can they grow and shrink? Why can you expand and compress a gas? I'm going to give you a sentence starter, and then I'm going to have you pause the video and try this one for yourself. Okay. In a gas, the particles, okay, and you're going to talk about the attractions versus the kinetic energy. Which one is winning? The kinetic energy or the attractions between particles? Okay. And based on which one's winning, what does that allow the particles to do in a gas that they cannot do in a solid? Go ahead and pause the video right now and try to write your own sentence. Alright, so you gave this a shot yourself. Here's my version. In a gas, the particles have a lot of kinetic energy. Relative to the attraction between particles. So the particles can move around and even spread apart from each other. Since the particles can move freely, the gas can change shape, and since the particles can get closer or farther from each other, the gas can expand or contract. In other words, the volume can change in a gas. Okay. If you want a sample of anything to change size as a whole, well, then the particles either have to spread out further to make the whole thing bigger, or the particles have to be able to get closer to make the whole thing smaller. In a solid, that can't happen. They're stuck in place, they're already touching, they can't get any closer, they can't go far away from each other either. Try a liquid. Liquids are interesting, right? You can change the shape of a liquid, but it can't expand or contract, can't get bigger or smaller. Okay? In a liquid, particles can, but they can't, right? They can do some things, but they can't do other things. Therefore, give it a shot. Pause the video. Here's what I was looking for in my sentence starter. In a liquid, particles can move around but they can't spread apart from each other. They are attracted enough that they stick together. So they can move around the sample, but they're attracted enough that they're going to stay touching. Okay, so therefore, the shape of the liquid sample can change, but the volume can't, because the particles can't spread apart. Okay, good stuff. Why can a liquid flow, but a solid can't? Right? You can pour a glass of water, but you can't pour yourself a glass of table. Doesn't make any sense, right? Why is that? Well, again, talk about the particles. By now, I'm not going to go over the answer to this one. I hope that you'll pause the video and that you're getting better at this stuff, right? What can the particles do in a liquid that solid particles cannot do? That explains it. Which states of matter can expand? That would be gases only. Okay? A gas is the only phase of matter in which the particles have enough kinetic energy to break free of each other, right? To overcome the attractions between particles. Being able to spread apart from each other is what allows the volume of the gas to change. Okay. And that's about it. We've gone for 16 minutes, and we covered some good stuff here. Good job. Where's the stop button? There it is. I found it. See you later.